Next examples is for us to solve for the integrating factors. So, di na to sa isolve ang ordinary differential equations because it seemed difficult siya. Although, mabalaan lang nato nga exact ODE siya. Okay? Number 1. Negative 2xy plus x dx plus dy is equal to 0. Okay? At so sa tanawon kung kuan ba siya, no? Kung exact ODE. So, perform sa tag-test of exactness. Partial m with respect to y. This is our m with respect to y, so this becomes only negative 2x. Yet, partial n with respect to x is equal to 1 naman eh, so 0. Okay, so this la parehas og mga partial derivatives. So we could conclude that this equation, as of this present form, is inexact. So if it's an inexact differential equation, we could try solving it using integrating factors. If integrating factors is difficult or impossible to solve, that doesn't mean our ODE is not solvable. It's just that we could not solve this using integrating factors or using conventional exact ODEs. No? There may be other methods on how to solve our given ODE. So, dili lang siguro exact or integrating factor, or it might not also be variable separable or homogeneous. Okay, daghan pa man gid kaayo og ways on how to solve ODEs. So far, 4 pa man atong na introduce. Okay, back to this example. It concluded na inexact siya. So, itong buhaton is find the integrating factor. So, we have two starting formulas. We could use 1 over n times the difference of the partial derivatives of m and n, or we could use 1 over m, the partial derivative of m with respect to y minus the partial derivative of n with respect to x. If ang outcome ani is a function of x and only x, we'll use the formula I is equal to e integral of g of x dx. If the outcome of this one is a function of y alone, we'll use this formula I is equal to e to the power of integral negative h of y dy. So question, what if kani nga equation atong gigamit and ang output ani is a function with respect to x? So clearly we could not use this, no? So there are examples nga ana may tabo. Or after performing this one, ang nigawas is a function lagi in terms of one variable pero y man. So dili gyapon na magamit. Dapat after performing this one, a function in terms of x only ang outcome, ayan na to substitute dire. The same with this one. Pangita na to ang difference sa m and n sa ilang mga partials, divide na to by m. If dili gani in terms of y only ang mugawas ng function, dili na to ni magamit. Okay? And we could conclude nga it could not be solved using integrating factors or exact ODEs. So back to our previous example. We'll first use this equation, kani. So 1 over n, what is n? 0. No. N is 1. Okay, dili 0. N is 1. Diba? 1 over 1. The difference is negative 2x minus 0. Therefore, our g of x is equal to negative 2x. And yes, it's a function of x alone. So, pwede natin i-substitute sa diring equation. You could find the integrating factor I is equal to e integral of negative 2x dx. I is equal to e to the power of, say integral sa x squared over 2. So, namatay 2 dilaan. So, this just becomes e to the power of negative x squared. So, muna itong integrating factor. Next, we'll try to see if i-substitute na to ni, or I mean, if i-multiply na to ni sa original given equation, if ma-convert ba siya into an exact ODE. Okay? So, let's try. Wait lang sa. Okay. Muna itong I. Muna itong original differential equation. So, I is e to the power of negative x squared. E to the power of negative x squared. I-multiply na to sa original equation. Negative 2xy plus x dx plus dy is equal to 0. Let's test. No? Partial of m with respect to y and partial of n with respect to x. It is m. Kanitanan. So, with respect to y, so this is a, kung ito na i-multiply dito, kay x latanan, so constant. Kung ito i-multiply dito, only y. So, the partial derivative of m with respect to y would only be negative 2x e to the power of negative x squared. Partial of n. So, partial derive na with respect to x. So, this is a composite function. So, how do we differentiate a composite function? Chain rule. Okay. So, e, just copy this one kay exponential function, e to the power of negative x squared. Then, derive again this one, negative 2x. Therefore, the answer is negative 2x e to the power of negative x squared. Okay, so pareha silang duha, no? So, we've successfully converted our original given inexact differential equation into an exact differential equation using integrating factor. Okay? So, stop right here lang ta because we've tried already na it may be a challenge to solve the differential equation. Okay? But anyway, if na-master na nato ang process of solving for the ordinary differential equation using exact method, no? So, there's no problem for us if magamit ang other examples. Okay?